Okay, so as promised in class, sections 4.3 and 4.4 are all about proving triangles congruent. That is our main goal. Okay, we are going to talk about 4 ways to prove triangles congruent. 4 ways to prove triangles congruent. And what's nice about these 4 ways is you only need 3 parts in each way. 3 parts. So if you think about a triangle, right, there's 6 parts. There's 3 sides and 3 angles. Well, in these 4 ways to prove triangles congruent, you only need 3 of the 6 parts. All right. So the first 2 are going to involve at least 2 sides. The first one is going to be side, 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 or typically what we call side, 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 SSS. Okay, and inside, side, side, the 3 parts you need are the 3 sides. So you need 3 congruent sides from each triangle. So what do you need? You need 3 congruent sides from each triangle. 3 congruent sides from each triangle. So if we draw a picture, we'll just draw a very simple picture right here. That'll be one triangle. Here's another triangle. Let's call this triangle M, N, P, and this one Q, R, S. And I'll mark one marking. Here, I'll use a different color. We'll use red. 1, 2, 3. 1, 2, 3. If you know that the corresponding sides of one triangle are congruent to the corresponding sides of another triangle, that is good enough to say that the triangles are congruent. We don't need to necessarily know anything about the angles. We are to assume that the angles are going to be congruent. There is only one way to draw a triangle if you know its 3 sides. If you know its 3 side lengths. So here, what we would say is that since, so we'll list it out. Segment MN is congruent to QR. We know that segment NP is congruent to RS. And we know that segment, we'll say MP, is congruent to QS. Since we know these 3 sides are congruent, we can now say that triangle MNP is congruent. MNP is congruent to triangle QRS. By side, side, side. There's the first way to prove triangles congruent. Okay, next. Side angle side is the next way. And we call this SAS, side angle side. So what we need here, the 3 parts, are 2 congruent angles. 2 congruent sides. So we need 2 congruent sides. And the congruent angle between. So we call it and the included. And the included. 2 congruent sides and the included angle congruent. Okay. So we'll draw a picture and we'll show what this means. But 2 congruent sides and the included angle congruent. Okay. That's the 3 parts you need to be congruent. So let's do another picture here. Draw 2 triangles like this. Let's call this one PQS. Let's call this one WXY. And there's how I'll mark it this time. I'll mark PQ, QS, WX, and XY. And then the included angle. So that would be angle Q here and angle X. If you think about the included angle, it's the angle between. The angle between the two sides. So here, what do we know? Well, we know three things. We know that segment PQ is congruent to segment WX. We know that segment QS is congruent to segment XY. And we know that angle Q is congruent to angle X. These three pieces of information create only one triangle in the universe. Any triangle that has this relationship is going to be congruent to these two triangles. So these two triangles are congruent to each other. So this information tells us that triangle PQS is congruent to triangle PQS WXY. Just by knowing two sides and the angle between. There's only one way to draw the triangle. All right. So these are the two with at least two sides. Okay, let's move on to the ones with at least two angles. Now, as I mentioned in class, these with at least two angles are going to really hinge off of the third angle theorem. Okay, so let's start with angle side angle, or more commonly called ASA. Okay, here you need two congruent angles and the included side. And the included side. Okay, so again, this word included. So what do we talk about here? Well, if we draw a picture like this, and if we draw, I'm going to make it a little bit more difficult. I'll draw this one upside down. We'll call this A, B, C, and we'll call this D, E, F. And again, what I'm going to mark is two angles congruent. Let's do A and C. So we go D and F, and then the side included, which would be AC and DF. So if I give you this information, okay, the two angles and the included side, or remember this included means between, so the side between the angles, then we can say that these triangles are congruent. Okay, so what we can use is the fact that, well, angle A is congruent to angle D, angle C is congruent to angle F, and the included side, AC, is congruent. Now, AC goes from one arc to two, AC, so you have to do the same thing here, DF. Even though DF and FD are the same, remember the correspondence has to be true. So knowing these three pieces of information, the two angles and the side included, knowing that they're congruent, we can say that triangle ABC is congruent. ABC is congruent to triangle DEF. Okay, and then finally, the last way to show two triangles are congruent, the fourth and final way, is going to be by angle, side. And again, this is AAS. Okay, so in angle, side, you need two congruent angles and a non-included side. Non-included. Non-included. Very important, okay? So if we take a look at these two triangles, okay, let's call this one triangle ABC again. This one will be triangle DEF. EF. And on this picture, we will mark two angles. So let's say angle A and angle F, angle C and angle D. But this time, we'll pick the side not between the angles. So not A, C, and DF. Let's pick AB and FE. Okay? So what do I know? Well, I know three things. I know that angle A is congruent to angle F. I know that angle C is congruent to angle D, and I know that AB, side AB, segment AB, is congruent to segment FE. Knowing those three pieces of information, I can use angle-angle-side congruence, angle-angle-side, to say that the triangles are congruent. Triangle ABC is congruent to triangle FED. Sorry, triangle. Squeeze it in there. Triangle FED. And there we go. So here are the four ways to prove triangles congruent. Now, ways not to prove triangles congruent. I want to go over these in class on Wednesday, okay? Ways not to prove triangles congruent. There are two ways. If we think about all the combination of letters we use, there are two ways. The first one would be angle, angle, angle. Okay? I'm sorry. Angle, angle, angle. Or A. The second way that we are going to show in class would be side, side angle. Okay? SSA. So these are the two ways we'll show how you can't prove triangles congruent in class. Alright? So stay tuned to the second video where we'll do some proofs.